Assalamualaikum warahmatullahi ta'ala wabarakatuh. This is the video of Group Project Hydraulic for Group 4. Before we go far, let me introduce the group members of this group. Me, Muhammad Zahir bin Abdul Rauf, and others friends which are Muhammad Sazani binti Zabri, Muhammad Yusri bin Mazlan, Nur Izzati binti Ahmad, and Nur Izzati Nabila binti Roslan. Before we go far, let me introduce about introduction of this project. Project group under hydraulics course is about stormwater drainage system. Stormwater drainage system is facilities that used for draining the stormwater, which is rainfall, from drainage area to the outlets such as ponds, lakes, stream, and river. The problem statement of this project is about flash flood that occurs at study of location, which is at Taman University, Bukit Raja. This location is around at University Tun Ocean Malaysia, which is the drainage system there experiencing flooding problems. From this project, we are proposing a new design of channel for new storm water drainage system. There are procedures that consist which are rational method and many equations to achieve this project.
My name is Muhammad Shazani bin Zamri, and I will continue our presentation with methodology. So basically, there are two general steps that we use, which is rainfall estimation method and peak discharge estimation. For rainfall estimation method, we use Manning equation. The Manning equation is basically an empirical equation that applies to uniform flow in open channels. The function of Manning equation is to calculate the channel velocity, flow area, and channel speed. This is the equation for Manning equation. Next is peak discharge estimation. We use rational method to calculate peak discharge. The rational method shows a relationship between intensity of rainfall and catchment area as an independent factor, while peak flow discharge as the independent variable caused by rainfall. Rational method is used in the analysis to obtain a discharge or peak flow rate for the chosen urban area. So this is the equation for rational method, and this is the formula to get drain flow, and this is the formula to calculate design rainfall intensity.
Hi, I am Izzati. I will talk about rational method that we use to find Q peak, and this is the formula that we use. As shown in procedure of finding Q peak, we need to find average rainfall intensity using this formula, which is constant value from Sektor Daerah GPS Batu Pahat as our station, since it is close to the site observed. We assume value of T is 25 years with storm duration calculated of 0.0817 hours. Thus, value of I that we found is 318.82 mm per hour. Next, we selected 0.9 for land use of lane and terrace house for runoff coefficient value based on the observation at the area. After that, we find the total watershed area of 13 hectares using Google Map. Once we got all the values, we calculate Q peak, and the value shown is 10.3 meter cube per second.
Hi, I'm Yusri. I will talk about proposed one-channel design. We select rectangular shape drain of new channel section with depth 1.4 meter, top width 5.5 meter, and water width 4.55 meter. Next is Manning equation by Q design. Step 1 is design channel array with formula A equal to Py plus Zy, where we get A equal to 7.034 meter square. Step 2 is design weighted parameter, same formula P equal to P plus 2y square root 1 plus Z square. We get P equal to 7.507 meter. Step 3 is design hydraulic radius using formula R equal to A over P. We get R equal to 0.937 meter. Step 4 is design discharge use N equal to 0.018 using formula Q equal to A times 1 over N times R to the power of 2 over 3 times S power of 1 over 2, we get Q design equal to 23.96 meter cube per second. Step 5 is compare Q design and Q peak. Q design is 23.96 meter cube per second, bigger than Q peak is 10.3 meter cube per second.
Hai, Assalamualaikum warahmatullahi wabarakatuh. Be back again. Me, Muhammad Zahir bin Abdul Rauf, version number DF210084, will explain about the factor of flood. We can conclude that there are two factors, which is external and internal factor of flood. The internal factor, the first one is sediment occurs due to erosions when the soil is less stable and soil will slowly move inside the channel. Second one, channel is not constructed perfectly by using materials such as concrete. This is because consideration of detail of channel is so important. And the last one, channel is not maintained because of grow long grass. And then the external factor, which is the external factor to let the flood is factor of rainfall intensity increase and to let water level increase because the ditch doesn't accumulate the flow.
Hello everyone, my name is Nurizati Nabila binti Roslan, number metric DF210047, and I will talk about proposed flood mitigation. The most effective flood mitigation measure is an efficient drainage system. The proposed flood control method is structural measures, which is improving the current drain with better design, and this is due to the fact that the flood affected areas do not have proper drainage. The drain that will be presented is a concrete type, trapezoidal shaped drain made of cement, sand and stones, and the present drains are only constructed with an excavator, but the intended flood mitigation design is refined with the task of excavating the ground, depositing sand, installing and compressing the drains, and connecting the ties between the drains. The usage of cement will result in the mean roughness to be lower than it used to be, which is 0.018, and this will result in the water flow freely in short time. The building of these drains will not only avoid flooding, but it will also ensure that road users in the surrounding region, such as UTHM students or residents who will be waiting at the bus stop, will not suffer difficulties such as slippery roads on rainy days and after rain. That's all from me. I will pass this presentation to my friend. Thank you.
For conclusion, in this overall of this project, stormwater drainage system is so important for the people to avoid flash flood occurs. From the existing drainage system at Taman University, Parit Raja is not accumulated for the heavy rain, and it can lead to flooding problems. It will give negative impact if there is no action from the authority to build a new design of the system. So, in this project, we are completely calculating the peak flow, which is 10.3 meter cube per second, and the new design discharge is 23.96 meter cube per second, which means that is enough to accumulate the peak flow if the heavy rain happens. That's all for our group. Thank you for watching. I hope you can enjoy this video.